Hi, in this lecture we will learn about differentiation of logarithmic functions. The formula to differentiate natural logarithm of x is just equal to 1 over x. A more general formula to differentiate natural logarithms with any function of f is just 1 over of that function multiplied with the derivative of that function f. This simply means if we have natural logarithm of function fx, and to differentiate it, it is just 1 over, copy the function f, exactly the same, do not change anything, and then just multiply with the derivative of that function f. Let's look at a few examples on how to apply this formula. Function y is given as ln 7x plus 3. ln stands for natural logarithm. The rules for logarithm applies. You cannot simply separate ln a plus ln b if there is a plus sign in this bracket. It is wrong. Okay? What you can separate is if the sign in the middle is multiplication. Like this. Natural logarithm of a multiplied with b, then you can separate it as natural logarithm of a plus with natural logarithm of b. Remember your law of logarithms. Remember not to separate it like that. It's wrong. So what you can do is just differentiate this whole function. This is your function fx. To apply the formula, we take all of the terms in this bracket as our function fx. Next, write the formula. Start by writing 1 over that function. So this is 1 over, all of the function is written at the denominator. Multiply it with the derivative of the function in the brackets. After that, just differentiate the function in this bracket. Multiply it with the terms in front. And since this is just 7, 7 is over 1. So you can multiply numerator with numerator, denominator with denominator. What you get is 7 over 7x plus 3. Now, pause the video and try to find what is the derivative of this function. Have you tried out? So to apply that formula, just write 1 over it with the whole function in this bracket. And then just multiply it with the derivative of the function in the bracket. Differentiate the functions in the bracket, just multiply it with the terms in front. Functions in the bracket is 2x plus 9, and this is just over 1, so numerator multiply with numerator, denominator multiply with the denominator, and your final answer is 2x plus 9. That's the simplified form. Next, for example 1c, before we start using the formula of 1 over f, right now the f is a function with power 4. So, if you write the bracket with power 4 as our function f, then to differentiate the function f, you will need to use power rule or chain rule. For this question, this is natural logarithm, so all of the rules of logarithm applies. Remember this one rule where we have natural logarithm of a to the power of b. What you have to do next is just to bring the power b to the front of the natural logarithm. Once you bring the power b to the front of natural logarithm, then it will be easier for you to differentiate. So always try to use the law of logarithm to simplify your functions first before you differentiate. So for this question, use this rule and bring that power 4 to the front of that natural logarithm. Next, you can differentiate. So 4 is multiplied with the natural logarithm. So just write 4, it's just a scalar. Multiply it with 1 over the function f, and then multiply it with the derivative of the function fx. Now, next, 4 is multiplied with 1 over 7x squared plus 5x. 4 is just 4 over 1. So you can multiply numerator with numerator, denominator with denominator. That's why 4 is on top of this fraction. And then behind it, just multiply it with the derivative of 7x squared plus 5x. differentiate this. 7 times 2 is 14, x per 1, and differentiate 5x, you get 5. Also note that this is just over 1, so you can multiply numerator with numerator, denominator with denominator. But do not expand this 4, because the simplified answer would be in the factorized form. So you can just leave your answer like this, or you can also factorize the denominator if you like. And that will be your final answer. Now look at example 2a. We have y equal to x cubed times natural logarithm of x. So what is the function right in the middle of them? The function is multiplication. And now we have two terms with x. So remember what we have to do when we have two terms of x and the operation in the middle is multiplication. What you have to do is you have to use product rule. So remember your product rule is letting your u and your v, writing them side by side. Next, differentiate u and differentiate v. So differentiate u is just 3x squared. Differentiate v, this is just ln of x. So what you get is 1 over x. Because if you apply the general formula, this is just 1 over the function f, and the function f is x, multiplied with the derivative of the function x. So when you differentiate x, you get only 1. So that's why your answer is 1 over x. This is product rule because the operation in the middle is product or multiplication. So remember your crossfish. Write down your formula v u prime plus with u v prime. Next, simplify anything that you can see and factorize. So there is x squared here and also x squared here. When you want to factorize, it means that you want to find the same factor on this left side, written as a, and on this right side, written as b. What separates them is this plus sign in the middle. It can be plus or minus sign. So make sure you have the same term to be factorized from the left and right side of this plus sign. And for this question, you can factorize x squared because there's x squared from the left and right side of the plus sign. So what's left is just 3 ln x on the left and plus it with 1 from the right side. And that will be your simplified answer. Next, example 2b. Remember, to solve differentiation of logarithms easily, you have to first use the law of logarithms if you can to simplify the function first before you differentiate. But for this question, can you use this rule of logarithm? Because you see that there is a fraction there. But can you use this rule? Well, you cannot use this rule. Why? Because this rule can only be used if there is only one log term, natural logarithm, and a big bracket with a fraction inside that bracket. But now, natural logarithm is only for the function on top at the numerator, but denominator, this is not inside the natural log function. So there are two different separate functions. So this is where we have to use quotient rule because we have x term at the numerator and also x term at the denominator, and we cannot simplify this. Separate the functions is wrong. Why is it wrong? Because look at the bracket. Plus 3 is also in the bracket of this natural logarithm. So that means the function 2x plus 3 cannot be separated. Remember the formula that I have written down, which is wrong? You cannot separate this into two logs. Once there is a plus sign in this bracket, they are stick together and you cannot separate them. The only way to differentiate is by using quotient rule. So write your u and your v, differentiate your u by using the formula to differentiate logarithms, 1 over the function 2x plus 3, and then multiply it with the derivative of the function inside this bracket. So when you differentiate the function inside the bracket, what you get is 2. So 2 is just over 1, so you multiply 2 with 1 and 1 with 2x plus 3. That's how you get this. differentiate your v term. Remember, to differentiate e power of x is just copying down the function as it is and differentiate your power. So when you differentiate x power 1, what you get is just 1. Now, draw your crossfish with the I negative I and over v squared. Write down your formula, v u prime minus with u v prime over v squared. Next, to simplify this, factorize any similar factors. The separation is right at this negative sign. So you have to find one factor from the left side and also one factor from the right side of this negative sign. Is there anything which is similar that you can factorize? Well, there is e power of x. You can factorize e power of x and write everything else in a big bracket. Divide it with ex power 2. So you can simplify it with the denominator, because ex power 2 simply means ex times ex. So when we want to eliminate 1 e power of x, what's left is just e power x. And e power x at the denominator, when you bring it up, what you get is e power negative x. So just multiply it with the other terms behind it. And that's your simplified answer. Now, look at example 3a. We have double natural logarithms in this one function. So how to differentiate? Don't worry, just be careful. We have to use this formula. So to use that formula, identify what is your function f. Your function f would be the function, all of the functions in the bracket after the first natural logarithm. So this will be your fx. So according to the formula, you just write 1 over that function f. So just write 1 over that function f. And then multiply it with the derivative of the function f. So just write down that function f there. Next is to differentiate the terms in this bracket. So to differentiate this term, this is natural logarithm. So you have to use this formula again. So to differentiate that, now the function is 1 minus 2x. That's the function for this logarithm. So when you differentiate it, you write 1 over 1 minus 2x and then multiply it with the derivative of that 1 minus 2x. And then just copying down for your next step and differentiate this term. You get negative 2. Simplify your answer. This is negative 2 over 1, so multiply the numerators together. 1 times 1 times negative 2 is just negative 2 on top, and at below, you multiply all of the denominators together. So just write down, usually we will write 1 minus 2x in front because it is not a term of logarithm. And then we will write logarithm behind. Why don't we write logarithm 1 minus 2x next to 1 minus 2x? Because you will definitely do this mistake where you might combine this as squared. And that's wrong. Why? Because this 1 minus 2x is not a logarithm function. It is just 1 minus 2x is a linear factor. So you cannot combine it with the function of this log. So this is a function of log multiplied with another linear factor. So to reduce your careless mistakes, just bring that linear factor to the front. Or if there is any other constant here, maybe for example 5, just bring that constant 5 to the front of natural logarithm. And always make sure your logarithm terms is behind of the other terms. Put the other terms, which is multiplied to the logarithm, in front of that log. Example B. Now, this looks complicated, but remember, if you can apply your law of logarithm to simplify the function first before you differentiate, that would be the best way. So is there any law of logarithm that you can apply here? Remember these two most popular formula for law of logarithms? Can you apply it here? One thing that you have to really look for is how many terms of log do we have in this function. There's only one term of log here. That means the rest is just the function of this log. That's why the fraction is right in the middle of this log, which refers to this whole function is the logarithms function. Use your previous knowledge. Now separate this natural logarithm. You can separate it because on top at the numerator, the operation is multiplication, so you can use the first formula of law logarithm, separate them and writing a plus sign in the middle. Next, all of these terms is divided with surd of 2 plus 7x. So when you divide, you can use the second law, which refers to the denominator will be minus with the natural log of surd 2 plus 7x. Now, is there any other law of logarithm that we can apply to simplify this function? Remember this popular law of logarithm, where if you have a power for this a, then you can bring that power to the front of that log term. So we have a power for this function. We can bring that power 4 to the front of log, but this is surd. You know that surd can be changed to power 1 over 2. So once it's power 1 over 2, you can bring that power 1 over 2 to the front of that log. Now here, the power of e is 6x plus 5. So that's the power that you can bring to the front of that log. And remember, what is natural logarithm of e is simply equal to 1. Why? Because natural log simply means log base e. Do you remember this law of logarithm? Where log of e base e is equal to 1. Log of a base e is equal to 1. So after we simplify, we can bring 6x minus 5 to the front, and natural log of e is just 1. Have we differentiated this function g yet? We have not. We have just changed the form of g. So the title should be gx. It's not g prime x yet. Now, I want to write g prime x. So this means this one line must all be the derivative of the function g. You cannot simply differentiate one term and then copy the rest. What you have to do is differentiate this first term, second term, and third term in one line. So differentiate this one by one. They are separated with plus and minus sign. So look at it one by one. So the first term that we can see is 4 natural log of x minus 3. How to differentiate that? 4 is a scalar, so just copy 4. And then this is natural logarithm of x minus 3. Remember, you have to use the formula of natural logarithm. So it is just 1 over that function multiplied with the derivative of this function. And you can write multiplied with d over dx, x minus 3 as the function, plus it with, when you differentiate 6x minus 5, only 6 is left, minus with, this is a scalar, so just write down 1 over 2 in front, and this is natural logarithm, so you have to use this formula to differentiate the logarithm, 1 over the function multiplied with the d over dx of that function 2 plus 7x, and then the next step is to differentiate what's in the bracket of d over dx and write everything else in front. So this is 4 over 1. Multiply numerator with numerator, denominator with denominator, and when you differentiate x minus 3, you get 1, multiply with that. You have plus 6 multiplied with this, so numerator with numerator, denominator with denominator, and differentiate this term, you get 7. Lastly, simplify your answers. Behind here, this is 7 over 1, so multiply all of the numerators together, you get 7 on top, and below is just 2 in front of this bracket. And that will be your final answer. Now try out these exercises. Exercise 1, 2, and 3. Thank you for watching.